Good day. Today we're going to be looking at key features of functions from our graphs. Alright, we're going to state the domain and range of these two functions in interval notation. This is just a quick warm-up to remind you of what we have been doing in the past lesson. On the function on the left, we have an arrow going to the left, the function is, and to the right, therefore my domain is going left and right, negative infinity to positive infinity, or you can say all real numbers. My range is starting at the bottom and going to the top, so that would be negative infinity to 4 inclusively. I'm wanting to make sure to put a square bracket on that y value of 4 because I am touching it. The next part, what is f of 0? If I go to 0 on my x-axis, go to my graph, 3 is my answer. Okay, on the left, it's going left and right. Therefore, my domain is all real numbers. Now, let's talk about the range really briefly for number 2. If you was to say 4, negative infinity up to 4, I would give you credit for that because the arrows are going down. This is supposed to be a trigonometric function, however, and the graph is oscillating. The actual range for this function is negative 4 to 4. F of 0, I said 0 and started to write it. F of 0 is 4. All right, that's review. Let's look at the new stuff. Intervals for increasing, decreasing, and constants. The main thing I need you to remember for this, you are reading from left to right. It's not up and down, and it's not right to left to right. A function is increasing if, as you read to the right, your graph goes up. There's the increasing. It is decreasing if, as I go to the right, it goes down. And lastly, it is constant if it's a straight line. It's not going up or down. All right, let's look at these two functions. Assuming the lines are continuous to negative and positive infinity, state where they're increasing, decreasing, and constant. If I start, I am decreasing. Then I have a turning point, which is going to be a relative minimum to increasing. I have another turning point to decreasing. So, before I do this, I want to get you to think about something else. What is my domain to this function? My domain of this function is negative infinity to positive infinity. The reason why I ask you that, everything on this graph is going to lie between negative and positive infinity. I have to have those. So, at the beginning of my graph, I am decreasing. So where is it decreasing? Well, I'm going to start at negative infinity, because that's the left side of my graph. And it's going to keep going down until I reach the x value of 0. Because I stopped at 0, it is now changing to either increasing or constant. In this case, it's increasing. So 0 up until 2. Now that I have it up till 2, it starts to decrease again, so I'm going to go back down to decreasing, put a union 2 to infinity. There is never square brackets on intervals of increasing and decreasing because a single point is not doing increasing or decreasing. A point is one part of this line. Constant, it's not applicable, it does not exist. All right, I'm going to show you the answer. Well, 4 is really quick. Let's just do it. Starting at negative infinity, I'm increasing. And then from negative 1 to infinity, it's constant. I wrote that in the wrong box. There we go. All right, moving on. Relative extrema. This is turning points. Now you're going to be asked about absolute maximums and minimums and then relative. An absolute maximum means the graph will go no higher. And absolute minimum, it goes no lower. Relative just means it is turning. So if we look at this example of the graph on our right, if I was to trace this graph, I get to -1, 2, and I turn. Because I start to decrease, this is a turning point. Likewise, at the bottom, 1, -2 is a turning point. -1, 2, our top point is a relative maximum. 1, -2 is a relative minimum. All right, use the graph to answer the questions. Indicate the intervals of which f is increasing. I'm going to skip increasing and decreasing. I'm going to show you the answers here in a minute because I'm sure you can do that. We've just now spent some time doing it. Let's look at relative maximum and relative minimum. Identify the relative maximum. I have a turning point at 0, -2. There is a relative maximum. I know it is a maximum because it's going down on both sides of it. Identify relative minimum. That would be 2, -3, and 3, -5. Really briefly on this, 3, -5 is the absolute minimum. It never goes any lower. An absolute minimum is still relative as long as there is a turning point. My absolute maximum of this graph is y equals 0. It is not a relative maximum, though, because there is no turn. That is something you need to make sure to keep in mind. State, domain, and range. All right, domain, -3 to 5, not including 5, including 3. Range, -5 to 0, including both. All right, let's look at how to use Desmos to do this. So use a graphing utility to approximate any relative maximum or minimum values. So I'm going to go to Desmos. Maybe, there we go. Type in your function, 2x squared plus 3x squared. No, that was a cubed. Plus 3x squared minus 12x. Okay, here's my function. There's my turning points. So I have my relative minimum and maximum. Relative minimum, 1, -7. Maximum, -2, 20. All right, let's move on. I'm going to show you the answers to A through K here in a second. I do want to look at G, I guess down to K. So for G through K is what we're going to be looking at real briefly. Values of x for which f of x is less than or equal to 0. So where is this below the x-axis? Well, I'm going to start my graph at -infinity. I'm going to be going up to -4 on my x-axis. Then I'm going to cross the x-axis, but I don't care about that point. I'm just looking to where it's below, so these two positions. That's one of my points, and I'm going to union that with 4 to infinity. The numbers at which f has a relative maximum. This says not what is it, it says where is it. The numbers at which f has a relative maximum. So I have a relative maximum at this position and this position. My relative maximum occurs at x equals -2 and 3. Now it says, what is the relative maximum of f? So I want my points. Mainly it's the y value, but I'm going to write the points. So at -2, it's going to be 4. And at 3 is going to be 2. What is f of -2? That is 4. The values of x for which f of x is equal to 0. Where is y equal to 0? That is going to be where it crosses my x-axis, -4, +4. Finished. Even and odd functions. An even function means I can fold it on half across the y-axis. What that means to the points. If you have point -2, 2, and I reflect this over my y-axis, I am changing the sign of my x value. So it becomes +2, 2. The graph will look something like this. It can be folded in half onto itself. An odd function is symmetric to the origin, which means I'm going to flip these signs of both x and y. So if this point is -2, -2, well, that's the point it gives you. I don't really like that though, so I'm going to change it. Let's use -1. Well, -1 and -0.5. If this is -1 and -0.5, I'm going to change the sign of both of these, and it is going to give me +1 and +0.5. I just wanted to use that coordinate so that you could see I'm flipping both signs. And my graph will look something like so. To be odd symmetric, it has to pass through the origin. It has to go through the point 0, 0. Folding wise, you are folding it across the y-axis. So I'm going to use the left side just to demonstrate. You fold it across the y-axis, and then you fold it across the x-axis. And the graphs should line up that way. That's how I like to view it. All right, let's move on. And here's what I just all said, wrote down if you want to write it down. Graphically determine if the function is even, odd, or neither. The first one, x³ minus x. Well, we can do this. Hopefully you can do it just by looking at it, but let's flip it over the x-axis or y-axis. I have this function. Now flip it over the x. I would have this function. This is odd symmetry. You could also pick points on this line. It's gonna work, it's the same thing. I'll show you that real quick, and then I'm gonna move on. If I pick point -1.5 and -1.5. 1.5 should be a point. So go to 1.5, go up, it is a point. It is odd symmetry. All right, x², if you was to fold it in half, the graphs would line up. This is even. All right, number 8. If you were to fold it in half, you're gonna have this graph. Okay, so I know it's not even. Now let's check for odd. If I was to fold it above the x-axis, I'm gonna have this graph, if I don't mess it up. That graph. My two lines do not add up, therefore this is neither. All right, that is all that we're doing today. I am gonna go through and show you the answers to the few that we skipped. So I'm just gonna scroll through. You can answer ones that we skipped. Mainly, I think it was this page. And on that page. Okay, that's all that we're doing today. Finish the assignment online. Have a great rest of your day.